Okay, ELE 112. This is another video on Thevenins Theorem circuit analysis, part 5, another working problem. Very similar to a homework problem, so if you run into problems with your homework, you'll come back to these videos. Take a look at this circuit. This is basically it's a series parallel circuit. The battery's in a weird spot. That's okay. We'll figure it out. We're going to solve for Thevenin. The first step is to open up the load RL and remove it. And as you can see in this drawing right here, where the red X just got drawn in, we took the load out, and that leaves a gap in the circuit. There has to be a resistor directly in front of that gap that forms that voltage. It cannot be 500 ohms on the right because the battery's in the way. It has to be the 1000 to the left. So, in other words, we are simply looking for the voltage across resistor 1. And that makes this circuit just a simple series circuit. If you look at it, it just flows in a circular direction. It's just a simple series circuit. So when we go solve for that first resistor, because it's a series circuit, the voltage divider works. And on the top of the voltage divider is resistor 1 divided by the sum of the two resistors. This gives you Thevenin, and if you run through the calculation, you'll see that you get 6.66 volts. Wow. Thevenin's theorem doesn't have to be hard. It doesn't have to be. It depends on how many parts are in the circuit. We're just rookies. We're starting with small circuits and getting bigger down the road. But look how simple. Basically, your biggest challenge will be identifying which part is doing the voltage drop where Thevenin is. There's always a part doing that. In this particular diagram, we want to do part 2, R Thevenin, of the circuit, and I've redrawn it up on top with the battery. Now, we have to take the battery and we have to provide a short circuit right here. We need to replace batteries with shorts and current sources with opens. That's our goal. So, what we're left with is a meter which sits right here in this space, and it sees two resistors which happen to be, with respect to where our Thevenin is being looked at, those two resistors happen to be in parallel. You could grab this resistor and put it right here. It's connected via a common wire here and a common wire here. It doesn't matter if you have it hooked to the left or you decide to hook it to the right across this 500 ohms over here. So, that being the case, our Thevenin is simply this particular parallel circuit calculation, and since the smallest resistor is 500 ohms, our answer of 333 ohms, 0.333, gives us our Thevenin, and looky, we've built a Thevenin circuit with a battery of 6.6, can't get the dot drawn, 66 volts. Interesting, no dots. There we go. Okay, that was from the last slide. Thanks again. I'll be sure to post another couple of practice problems shortly.